So we consider how to do FTIR analysis, and we've gotten our spectrum. There's a variety of ways to approach this, but in general what we're going to be doing is comparing what peaks we see on the spectrum to what we know about where different bond frequencies are. Okay, so what I have here is just one of many possible general plots. You'll see ones if you just search FTIR interpretation. There's lots of guides that are just kind of quick reference guides, and this is one of my favorites because it's fairly simple and straightforward, but there's a good amount of detail here. And I've actually drawn a couple of lines here at the 3000 wave number, the 1500 wave number, and the 1000 wave numbers, just for my own reference, so I can kind of see how these align with each other with the varying wave numbers. So a couple of the things that I want to point out, and there's a much more detailed walkthrough of all of the different stretching, bending, rocking kinds of motions in the spectrophotometer or FTIR interpretation handout linked on Blackboard, and you should read that. But what I wanted to do here is show you kind of my shorthand notation and how I approach annotating spectra, because you will be expected to annotate spectra as part of your practice set. So here's how I kind of get started. I always kind of keep a reference like this handy. You can draw one of your own using the guide in the on Blackboard, or find any of the others, or you can use mine as well. Okay, so I'm just going to use examples from the guide just to keep things consistent across different areas. But so here's an example. This is an example of an alkane. But if the spectrum is all we have, the first thing I'm going to do is I always draw a line right around 3000. So here's 2000, 4000, here's 3000, and I'm going to draw my line up. And I can, even if I didn't have numbers associated with these peaks that tell me this is less than 3000, I would know that this is just less than 3000 because I've drawn my 3000 line. And on my guide, this 3000 line, the reason that this one's important is because that if you have a CH stretch, if this is an alkane or a carbon-carbon single bond, then that the carbon is attached to, this CH stretch is going to fall on the just shy of 3000 mark. Whereas if this carbon is attached to an alkane as part of an alkane bond, a carbon-carbon double bond, it's going to fall just above the 3000 mark. So here I know that these are CH stretches, and this is specifically a single bond CH. So I know I have an alkane. Okay. And to confirm this, I would go looking for other spots. Anything less than about 1600 or 1500 is starting, well, 1500 or 1000 is really starting to be called what's known as the fingerprint region. So in this region, you get a lot more information about specifically how different functional groups are connected to each other. And we won't spend too much time delving into the fingerprint region itself, but what I would look for are something like a CH scissoring or a CH rocking as well, to confirm my call that this is some kind of an alkane. Now I may not be able to get all the way to octane specifically, knowing exactly how many carbons there are, but I would at least be able to classify this as an alkane because we have this nice CH alkane stretch, and then the scissoring and methyl rocking that go with it. And there's not much else on this spectrum. So let's look at another example here. This one is an alkene. Now if I were to draw my 3000 line, okay, I'm going to start with my line at 3000. I can see that I have alkane, my CH stretch that goes with an alkane, but I also have something just above 3000, and this indicates the alkene CH stretch. So do keep in mind that this 3000 line is a real quick way to say, do I have only alkanes or do I have some alkenes as well? And when you look down at the lower numbers, we're still seeing our CH scissoring, our CH rocking like we saw with an alkane, but we're now going to get some stretching that goes specifically with the carbon-carbon double bond and stretching or bending that goes with the carbon-carbon bonding, carbon-carbon double bond with the hydrogen attached. Okay, so those are other things I would look for. Now, sometimes we have other functional groups other than just hydrocarbons, and there's a whole bunch of different ones listed in that IR tutorial, and I suggest you take a look at all of them. However, one of the quick ones that I wanted to show you is in alcohol. Okay, I'm drawing my line at 3000. We have a carbon-hydrogen stretch. This is going to be an alkane stretch, okay, because it's just shy of 3000. But then I have above 3000 a really broad peak, and what we're looking for is this broadness. Okay, if we get a broad peak, this is indicative of an alcohol. If this was a much narrower peak and looked more like what we're seeing with these narrow peaks here, it's probably more likely to be an amine rather than an alcohol. So keep in mind peak shape also plays a big role in determining what is present in our molecule. Okay, so we're also looking with the alcohol for this carbon and oxygen stretching, and if we went through some of these, we'd see these are some alkane stretches as well. So those are kind of what I'm looking for. So I would annotate my alkane, annotate my broad peak for my alcohol, and annotate that this is a carbon-oxygen stretch. And that would be sufficient for showing this is likely an ethanol structure. All right, the last one we're going to look at. All right, again, we're going to take our 3000. And you can use a ruler for this. I'm not so great at drawing straight lines, but oftentimes I'll go back and check this with the ruler just to make sure I didn't, my line didn't curve too much. But here we have our CH stretch. We know this is less than 3000, so this is an alkane. And we don't have an alcohol here. Although we've got a little something on here, but this is not that big, broad peak that we saw with an alcohol. And what we do notice is something around 1700. If you're looking at something at 1700, 1750, somewhere in there, that's nice and strong, sharp peak, that's almost always a carbon-oxygen double bond. Okay, it's a quick check for a ketone or aldehyde or carboxylic acid. If it's got that C double bond O, it's going to come into the 1700 range. And we could go through and annotate some of these as well as our alkane functional groups. Okay. So that's just a quick guide to checking out our spectra and how to annotate them, and I hope it helps you as you start working through your IR tutorial, as well as the practice homework that will ask you to specifically annotate a variety of spectra along the way.